Hello students, welcome back. Let's go over to problem number 2 again. This time, let's use the third method, the hybrid method. We have sample statistics like these, and the question is about exceeding 7,000 or not. So based upon that, we can set up hypotheses like this. Same as null, and the problem said exceed, so exceeding 7,000 significantly. So those are my hypotheses, and let's test these hypotheses using now hybrid method. Hybrid, a partly critical value, partly probability value. We do both, which means we find out t-statistics, and then we also find out critical value. And let's do this. Our textbook author covers this method as well. Call it classical approach, I think. Anyway, here we go. And we have to use t, not z, because the original distribution is believed to be normal. Okay, this is coming from observation, from experiment, without any kind of significant bias. The original standard deviation is unknown. Of course, unless you break everything and find out, break every lumber product in the world. Unless you do that, you cannot find out the population standard deviation, the original standard deviation. So it's meaningless. Number 3, sample size is small. 30 is pretty small sample size. And in this class, I'm using the threshold of 100. So 30 is less than 100. Hypotheses, all right. And sample statistics, yeah, all these we discussed. Okay, all right. Initial picture looks like this. Outline, the center is the null, of course. Oops. Okay, sorry about that. This is hybrid method, so center is not null, center is 0. And we just draw the standard t-curve. So center is kind of meaningless. And then we'll find out t-statistic as critical t-statistic. And then find out the t-statistics for the observed mean, and then whether that goes to blue or red. And that's the idea behind this hybrid method. In my opinion, overly complicated, but this is what our textbook author does. Okay, find out the t-statistic from the observed mean. What do you have? 7,203.19. Okay, so that's the end. And the center is, of course, null, 7,000. So we have that, n minus center over SC. And run your calculator, and 2.05031. Same number as you got as in solution 2, probability method. So far, this method like probability value method. But instead of calculating the probability value based upon this one, we do this. And find out the t-statistics associated to the probability is 0.05. Let's go to the t-table. This has to be 0.05, 5%. And the degree of freedom, as usual, was 30 minus 1, 29. It's already highlighted here, 29. So let's look at this row. And we are looking for 0.05, 5%. Okay, this column, let's go down, 1.699, and that's something you have to compare. 1.699 is the threshold or the critical t-score that goes over here, 1.699. And then the other t-statistic we calculate is 2.05. Does it fall red? And that's what the conclusion is all about. 1.699 is the critical t-score, and the t-score you calculated from observed mean was 2.05, and it falls in the red region. So alternative wins, and we reject null and accept alternative. How do you like this method? Do you like it? I don't, but our textbook author calls it a classical method, and he explains it. It's okay, but in my opinion, it's just okay. In my opinion, the best is this one. Let's see. Initial picture looks like this, centered at the null, all right? And then just find out a critical value. So mu is greater than mu0, so greater, so right hand side, and then find it out using the typical t-score formula. N minus center over SC is a t-score, which you can find out from the t-table, 1.699. Solving this equation by flipping over denominator to the other side and so on, we get the solution, and then punch your calculator, you're going to get a value, and compare that value with your observed mean, 7,168 versus 7,203. It falls in the red region, alternative region, and that's how you test. In my opinion, this is the best, easiest to understand, and okay, I take it back. The best method in terms of student score, the student who used the critical value method usually score the best, so I've used the best. But personally, the method I'm using when I have to use is actually probability value method, the second method, just like our textbook out there. The reason, and this one is easier to apply with technology, not going through the table. So that's why I do solution 2 when I have to do my own. But when I teach, I do it this way because it usually generated the best result for students. Confidence interval method. Let's see. If you're not interested, then you'll probably end up just cutting off this video, so let's talk about it anyway. Just find out confidence interval, one-sided confidence interval, and then find out whether 7,000 falls into that confidence interval or not. So it's a confidence interval problem that we did exactly as in problem 1. So it is centered at the observed mean, and then you have to draw a kind of picture like this, 7,203, and then lower confidence bound, let's find out, and then 95% confidence interval, which is one-sided confidence interval, is this blue, and that's where the null is hypothesis wins, because null is going to be very close to this observed value. And if the 7,000 falls to this red region, then alternative wins because it's far away from 7,203 something. And in this case, if you do the computation accordingly, let's see. Yep, n minus center over SC. And then, oh, excuse me, this is unnecessary. I didn't have to copy and paste this one. Sorry, n minus center over SC. And then it turns out 7,034.799 is the critical value below that observed mean of 7,203. So it's here, and where is 7,000? It falls over here. This method is pretty much identical to the first method, except that it is centered at the observed mean and a null is floating around. So it's kind of weird, but it has its own advantage. This connects the confidence interval computation that we did earlier and the hypothesis testing problem we are doing now in the most natural way. You see, confidence interval idea and hypothesis testing idea are actually the same. And the only difference is actually just a little bit of change of signs. And the final method, the fourth method, actually joins them together. So it's important in terms of theoretical background, theoretical foundation, but I see most students in 1680 are not really interested in the theoretical foundation, so I'm not going to emphasize it very much. That's why I'm burying it toward the end of all these discussion, which probably everybody will be skipping anyway.